Hello everyone, welcome back to my YouTube channel. So today we are going to discuss on the class activity for chapter 3. Altogether we have two different questions and let's get started with the first question. In the first question, the first order reaction from A to form B, the half-life is equivalent to 0.1222 seconds. And if the initial concentration is 0.5 molar, how long for the final concentration to become 0.124 molar? To answer the first question, there shall be two parts. So the first part of the answering strategies is that you need to calculate the half-life of this reaction. If you read through the question, given that the reaction shall follow the first order reaction, therefore the half-life for the first order reaction is equivalent to ln 2 over k. So what you need to do is that you need to find the value of k, because given to you is the value of half-life. So the value of half-life is equivalent to 0.1222. Therefore, it's equivalent to ln 2 over k. Hence, k is equivalent to ln 2 over 0.1222. Therefore, you should get the value of k equivalent to 5.6722. So this is the first part of the calculation method. And then what you need to do is that, because in the question you were asked to calculate how long for it for the reactant for the AT to be 0.124 molar. So since this reaction is following the first order reaction, therefore you need to use the formula for the first order reaction. Ln AT is equivalent to negative KT plus ln A naught, where A naught is the initial concentration and AT is the final concentration. So from here, what you need to calculate is the T, the time, the duration, right? Because the concentration for the initial concentration and the final concentration is given to you in the question, and you already calculated the value of K. So you just need to plug in all the values. So it shall be ln 0.124. You can check in the question. The final concentration is that. And then negative K. Your K is 5.6722. T plus ln. Your A naught is equivalent to 0.5, just like it's stated in the question. Therefore, after you have calculated all this, you shall get T is equivalent to 1.3944 divided by 5.6722. So you shall get the value of T equivalent to 0.2458 seconds. So this is the final answer for the first question. Moving on to question number 2. If the rate of formation of ammonia is equivalent to 0.345 mole per second, what is the rate of disappearance of H2? For you to answer this question, you need to write the rate expression. So given in the question is the chemical equation, which is N2 plus 3H2 shall produce 2NH3. So from here you can write the rate expression. So rate is equivalent to negative, because these are at the reactant, so negative delta concentration of N2 over delta T equivalent to this one, have 3, negative 1 over 3 delta concentration of H2 over delta T equivalent to 1 over 2, because this is product, so it should be positive, delta NH3 over delta T. And then if you read again in the question, given that the value for delta NH3 over delta T, this part is actually equivalent to 0.345. So you just need to plug in the value here, because you were asked to calculate this one. So in saying that, 1 over 3 delta H2 over delta T is equivalent to 1 over 2 times 0.345. Therefore, you need to calculate this part. You should get, this one should be equivalent to 0.1725. Right, but you were asked to calculate the value for delta H2 over delta T. So you need to bring this up. So 0.1725 times 3, you shall get, this is equivalent to 0.5175. Alright, and then you need to check again the location of this. So since the H2 is at the reactant, so delta H2 delta T should be equivalent to negative 0.5175. So this is the final answer for the second question. Thank you very much for watching this video. I wish you all the best for your quiz this evening. So good luck and see you again next week. Goodbye.